once again. Last time we did in our node editor video, we were left somewhere around here. We had our input nodes over here. We see how to make a calculation node where we can have multiple math functions over here, and comparison node with great, less and equal, and an input node where it can give us a random number with from and to values we gave it, and of course our output node, so that we can see what's the result of our comparison node or any other nodes. So let's just see some more examples on this. Let me close that. Let me open up our scripts. So now, because we want to use some more nodes and different types of nodes, we'll go to base node and add, where is it, and add a new function which we will call public abstract, and it's going to be an abstract, so that means every child must have this, and we pass a float which we will call float delta time. So we will put a tick to our nodes so that they're going to be updated independent of their focus state. So this will make our nodes update even if we are not on that window. So if we are in the scene view, they will still be updating. We still see our nodes updating in their node window. So since we passed the new function to our base node, we have to go to every child and add this also, but in our base input node we will make this an abstract class, and instead of returning the get result, instead of returning none over there, we just make it into a string which we will call node result, and we make it to equal none, and we will calculate this value from the tick and not from the get result, and we will simply say this to return the node result. That's for the our base input node. Let's see our calculation node. We will go to get result. We will make it into a function which we will call tick, and of course we will pass float delta time, and instead of returning the result, since this is a function, an empty function, a void function, we can use return. We simply say node result equals result. Now to our comparison node, we will do the same, which is public override void tick float delta time, and the node result will return the result. On our input, let me just save, and on our input node we will say on draw window we will add to the end the node result will be the input value and we turn it to string, and of course we need to pass the abstract void, and we do this by override void tick float delta time, and we leave it empty since this is an input node. And our output node we will pass the abstract function let me just see quickly if we have anything else we need to change over here. No, we don't, and we will save. So now that we have this, we can simply use, we will go to our node editor and start make it so the windows are drawn. We call the results with our own delta time, and in order to do that we will actually call private system dot diagnostics dot stopwatch. This is a function, a C# function we use, and we simply say new system diagnostics stopwatch. And now that we have this, we can simply say in our show editor, which is when we first open the window, we will call the editor and we will say call the stopwatch function, and we use start. We use start when we want to start counting, and we can use reset, it returns it to 0, and if we use stop, it stops to the current second we are. So since it's the first time we do it, we want to use start, and we can actually call the update for the editor window, and over here we will say we want to use a long float which takes higher values than the regular float. We will say stopwatch, and this and we'll say stopwatch dot elapsed milliseconds, and this will give us the time in milliseconds, so that's why we use the long float. And then we will turn the long float into a regular float, which we will call delta time. We will cast it as a float. We will say d time, and because it's in milliseconds we want to turn it into seconds, so that's why we subdivide by 1000. And we can simply say then for each base node be in Windows, so for each base node we have in Windows, we can simply call our tick and pass the delta time. And now we can use stopwatch.reset so that it returns to 0, and after that, because the reset it's also makes the watch, our stopwatch, to be at 0, but it also stops it, so we need to start it again. And lastly, we want to repaint. Now this repaints this will repaint every frame. So keep in mind that for optimization reasons in the future. And now that we have this, let's go back to Unity, let it compile. Let's make sure that we have our nodes and they all work, just so that we didn't forget to add something. This is an output node, activation, comparison node, and randomization from 5 to, let's say, 30. Pass this and calculate the random. So everything works right now. So let's just see some more examples for our nodes. I'll just leave it something like that over here, just so that I have access, or maybe I just dock it, or anyway, we'll just close it and we will see later how to fix it. So let's create some scripts. The first, we will say game object active, which we will turn on and off a game object. The second one, we will say game object distance, which will give us the distance between two game objects. And the last one will be node timer, or maybe let us call it timer node, which it will count the time. So open up the game object active. We of course want to use the namespace of Unity editor. Now keep in mind, since we are using the Unity editor class, this cannot be introduced, cannot be compiled into a game. So on later videos we will see how to make it into an asset, save it and use it when we inside our games. So a game object will have an input, which is an input node. Of course we want to save the rectangle. These are pretty much the same with our previous. We have done this before, so if I'm going too fast, it's because we actually have done it before. The new thing we add is, of course, the private game object, which is the control object. So we call the function public override, which is our draw window. We want to use everything from the base class. We want the event. Of course, string input 1 title starts with the none, and if input 1 not equals null, input 1 title equals input 1 dot get result, and we close it. We need the label, of course. GUI layout dot label, and is input 1 plus our input 1 title, and we can say if dot type equals event type, dot repaint. We want to return the GUI layout utility and get the last rectangle which we clicked on, and we want to make an object field so the user can drop a game object, and we can say control object equals, we cast it as a game object, and we say editor GUI layout dot object field controlled game object, and this needs a type, which the type of is of course a game object, and allows in objects is true. So now we have our draw window. Let me just zoom in. Let me go a little further down. Now we need our tick function. Of course, we need this a float delta time, and we'll say if input1 not equals null, if controlled where is it, if controlled game object and if input one dot get result dot equals to true, control object dot set active true, else controlled game object set active to false, and this will simply turn it enabled or disabled according to what the result we get from our input node. So next off, public override, we want the set input, which of course this takes a base input node which we'll call input, and a vector2 which we'll call click position, click post.x minus window rec.x. We have done this before, so I'm just blazing through them. Input rect dot contains click position and input 1 equals input of course the node which is deleted, and this is if node equals input1 equals null, and then public override base input node clicked on input vector2 position, and we can say base input return value equals null, position dot pos.x minus equals window rect.x, pos.y minus equals window rect.y. If input 1 dot rect input 1 rect dot contains position, return value equals input 1. What did I miss? And input 1 will return it to null. So yeah, MonoDevelop has some weird glitches sometimes. And return the return value. And finally, of course, we need public override void draw course if input 1 not equals null, rect window rect dot x input 1 rect dot x rect dot y plus equals input 1 dot rect dot y plus input 1 rect dot height subdivide by 2 so that we get the center, and the width will be 1 and the height will also be 1, and node editor dot draw node curve input 1 dot window rect, and we pass the rect. So this is our game object active node. Now that we have this, we can simply go to our node editor and to our context menus. Let's just add separators just so that we know the new stuff we added in this video, and we can add a new content, a menu content. We will say add game object node false, and the context callback we will pass the string to go active, and after that we can go to our else if statements, to our context callback input. Let's put it to the correct position, else if and over here we'll say if our callback dot equals go active. Let's make sure that this is the correct string, so I just copy paste it. Go active game object active go node equals new game object active, and go node dot window rect new rect. We of course want it to be on mouse position X, mouse position dot Y, 200 and 100, and we add it to the windows, and of course we want to be go node. So this will probably so we have one error. Let's see why. Yes, we have wrote the tick. We have a spelling error on tick. And let's open our node editor, add an input node, add the game object node. Let's add a comparison node. So we have value of 1, value of 3, and we do a comparison and we pass the result. If 1 is greater than 3, it will returns false to our game object. So we need to drop a game object. I'm just using the light, and as you can see here, if it's false, it returns it, it closes the directional light, but if it's true, it enables it. So just leave it to 5 for now, and let's just dock it over here, and let's see a game object distance. So for this, we of course want the Unity editor. We want this to derive from base input node. We don't want this. We need two game objects, which we'll call object 1 and object 2. We want our constructor, game object distance, window title will be game object distance. We don't want to have inputs, so next, public override void draw window. We want the draw window from our base class, and object 1 equals, we cast it as a game object, and editor GUI layout dot object field object 1 type of game object and true. Copy and paste that for the second game object, object 2, object 2. We need to pass the abstract class, and of course we need to pass the tick, which is float delta time float return value. We start at 0 and we'll say if object 1, and so if we have an object 1 and we have an object 2, the return value equals vector 3 distance, and it's the object 1, the position of the object 1 to the position of the object 2, and the node result equals return value to string. Let's go into our node editor So let's start, since we are over here, let's start by adding the callback first. CLB dot equals, let's call it geo distance, and this over here, game object distance, geo distance equals new game object distance, geo distance dot window rect equals new rect, mouse position dot x, mouse position dot y, 200, 100, and windows dot add geo distance. Copy that just so that we have a correct the correct string. I'll just comment it over here, copy this, copy paste it, add game object, add, let's call it simply add distance node, copy the string for the callback, save, and if we go back, so now that we have this, we can simply, instead of using an input node over here, I'll delete this and we will add a distance node. Let's drop our main camera over here, and the second game object will be the directional light. We pass it into the comparison node and let's make it at the distance to 10. So if it's greater than 10, the distance, it will make the directional light to true, and if it's lower than 10, it will make the light to false. Let me dock over here. So if I select the camera and move it closer, you can see in the camera preview window, or let me just use the camera over here, you can see over here that if we are close to the light, we disable the light. If we are far away, the values we put over here, if we are far away, then the light is open. So let's go back to our final example, the timer node. Of course, we want to use Unity editor. It derives from base input node. We don't want this, and we want a float for how many seconds it's going to be enabled, for how many seconds is going to be disabled, we want, of course, a timer, so if this is true, it will move the timer until we have reached the enabled seconds. And of course, private, we want a bool which we'll call current result, and we give it a false. So timer node, public timer node, window title equals timer node, public override void draw window, and we want everything from the upper class, and we want to try and make the editor our text field, seconds to enable, and we pass the enabled seconds, but we pass it as a string, and all this will be out enabled seconds. Copy all that and paste it, and instead of enable seconds to enable, we say seconds to disable, disable seconds to string, and out disable seconds. So we want a string which we'll call status equals seconds to enable plus enabled seconds minus status timer, and we'll say if enable wait status equals seconds to disable plus disabled seconds minus status timer, and of course we want to be able to see that, so we say editor GUI layout dot label field status. So of course we pass the abstract class with our float, which we'll call float delta time, and if enable wait, if status timer is lower than enabled seconds, status timer plus equals delta time, else status timer equals 0, enable wait equals false, current result equals true. But if we are not, so else if it's not enable wait, and if status timer is lower than disabled seconds, status timer plus equals delta time, else status timer equals 0, enable wait equals true, current result equals false. And after all this, we want node result to equals the current result, and we pass the current result to false. but it will actually it will actually make the first letter capital. So if it passes true, it will actually pass true with a capital TAF. So because we are comparing a string to string, it will actually don't take it as a true. So we simply say after to string to lower, so it makes everything lowercase. And that's it for the timer node. So the last thing we need to do, let's add over here, maybe we'll call it timer node. Let's call it timer node. Let's go back to our callback. And we will say else if, and if our callback clb dot equals timer node, then as we did before, timer node t node equals new timer node, and t node dot our window rect equals new rect. Of course we want our mouse position, mouse post.x, mouse post.y, 200, 100, and we say windows dot add t node. Save it over here, and let's go back to Unity. Let it compile. Let me dock this over here. We have our game view so that we can see our changes, and over here we can say add timer node. As you can see, because it's both values are 0, it does this thing over here. So let's just make it 10, and you can see it starts counting seconds until it returns. So let's make it for 10 seconds to be true and for 10 seconds to be false. And let's make the transition and put it into our game object, into our active game object. So after 10 seconds it will either disable it or enable. So this is it for our video. This one was a little shorter. So of course we can use this stuff as it is right now in play mode, and if we hit play and see, we actually lose all our nodes. So these are not saved, but in the future we will see, in later videos we will see how we can save it and actually utilize it inside our games, just similar to how the animator and mechanism works. If you see over here, this is Unity's own state machine. So in later videos we will see how we can actually use these examples inside the game, so just so that we can make you understand. Anyway, so thanks for watching, and I'll see you next week.